I am Emel Abdul Majid and my supervisor is S. Chaprat. We are from University of Technology Malaysia. The paper I am going to present is Adapting Market-Oriented Policies for Scheduling Divisible Loads on Clouds. Cloud computing is a type of parallel and distributed system consisting of a collection of interconnected and virtualized computers that are dynamically provisioned based on service-level agreements. It has been a compelling paradigm for solving big data processing in science, engineering, and analytics. As cloud computing solutions gain the attention in commercial markets, several IT vendors have started offering prices in a flexible manner. Unlike the traditional pricing model adopted by Amazon EC2, in which users are charged based on the number of predefined VM instances, but, using this new performance-based pricing, users are merely charged based on the computing required. In other words, it costs more when users choose a faster resource. For example, in the pricing model implemented by Cloud Sigma and Elastic Hosts. This new pricing strategies allow cloud users to customize their virtual machines with different configurations and prices according to their budget and the quality of service expectations. The workload allocation approach present in this paper uses divisible load theory, DLT. It is based on the fact that the computation can be partitioned into some arbitrary sizes, and each partition can be processed independently of each other. With the assumption that users are more interested in completing a job within a specified budget and deadline on clouds that provide CPU resources with different configurations and prices, this paper is concerned with the investigation of adapting users' preference policies for scheduling real-time divisible loads in a cloud computing environment. Initial studies of divisible load theory, DLT, paradigm in the case of cloud's environment were mainly focused on the minimization of execution time and energy. The monetary cost optimization was considered in Abdullah, M. and M. Othman work. However, all the computing nodes were considered homogeneous in terms of speed at a CPU frequency. Furthermore, deadline constraint workloads were not dealt with. In a workflow-based scheduling in clouds, division policy enabling the parallelization of scientific applications to satisfy both deadline assurance and cost minimization was studied by Kim et al. However, load fractions in uniform manner, equal partitioning, were identically processed and optimal partitioning principle in divisible load theory, DLT, was not used. This paper is concerned with scheduling cloud resources that are heterogeneous with different configurations and prices. In addition, the scheduling also considers users' preference on their cost budget constraints. Workload real-time divisible load theory, RTDLT, used in this research is described here. The workload model in RTDLT allows for the parallel execution of a job upon multiple processors. Each divisible job JI consists of a single invocation characterized by ordered pair, sigma, D, where sigma is more than 0 is the total load size of the job and D is more than 0 is its relative deadline, indicating that it must complete execution within D time units of arrival. The proposed architecture for scheduling divisible load on cloud environment is described in this slide and the next slide. This slide shows the centralized scheduler denoted as head node P0 is responsible for scheduling loads on computing nodes. It has all the information about loads and capacities of computing nodes. The scheduler needs to assign loads to compute nodes denoted P1, P2, P3 up to Pn. The head node does not involved in the computation. Its role is to accept or reject incoming jobs, execute the scheduling algorithm, divide the workload and distribute data chunks to the computing nodes. This figure illustrates the scheduling framework upon heterogeneous resources in cloud computing. In this paper, the computing nodes that are heterogeneous in terms of speed and cost characteristics are looked into. Most authors in the divisible load scheduling literature consider three strategies, which are scheduling strategy, node assignment strategy, and partitioning strategy. Hence, another one strategy is that, Worker selection strategy is adopted to investigate the impact of worker order selection towards reducing computation cost. The selection of workers in cloud computing currently is done using a simple round-robin scheme, and the importance of worker selection has been highlighted in the literature. As shown in the diagram, each job arrival will be arranged in the queue. The scheduling strategy to determine the job order, the node assignment strategy to decide how many computing nodes are required for the job execution. The third decision is partitioning strategy to determine a strategy to partition and compute the chunk size of load to be processed and transmit them to each compute node's FATA switch. Two different partitioning strategies are investigated in this paper, the optimal partitioning rule, OPR, and the equal partitioning rule, EPR. The OPR is a superior partitioning strategy based on divisible load theory, DLT. It states that the optimal execution time is obtained when all nodes allocated to a task complete their computation at the same time. For comparison, a baseline approach that is equal partitioning rule, EPR, is adopted. If no schedule can be found to satisfy job's timing requirements, although enough virtual machines have been added, the job will be rejected. Our proposed market-oriented real-time divisible load theory scheduling algorithm named MORTDLT, allows user to choose faster resources or slower resources according to their preferences in terms of their cost budget and job priority. Each resource has its own computing capability in terms of speed represented by the number of instructions per second, MIPS. The algorithm aggregates resources into groups. The user sends the priority flag of each job they submitted. The divisible job will be distributed among the resources based on the priority. The tasks with low priority will be sent to the slow resources. The tasks with high priority will be sent to the fast resources. To observe the impact of selection of users' preference and job priorities to the cost, 3 sequence sorter strategies were examined. The results of optimal partitioning rule based on divisible load theory, DLT, with worker selection strategy according to users' preference is compared against the baseline approach, namely equal partitioning rule, EPR, where the fraction of loads is distributed equally among all the available resources. The results of the 3 approaches, that is high cost priority, low priority and random with the varying load sizes, are measured. For users with a high priority job and they are willing to pay more, they can submit the job with high cost priority flag is on. In this option, the scheduler will first choose the processors within the fast speed group, then it is followed by the slow speed group processors. The experimental results are showed here. This figure shows the relationship between the total cost and load sizes from the proposed algorithm when the user's preference cost priority is high for the different number of processors, N. From the results shown here, EPR yields a lower cost than optimal partitioning DLT high priority. The algorithm distributes fractions of load to the more powerful resources because user is willing to pay more to process their job. For users with low priority job whom would like to pay at a minimized cost, they can submit the job with low cost priority flag is on. In this option, the scheduler will only choose the processors in the slow speed group. The experimental results are shown here. This figure shows the relationship between the total cost and load sizes from the proposed algorithm when the user's preference cost priority is low for the different number of processors, N. From the results shown here, a significant cost reduction can be observed when users choose to pay at a minimized cost to process their job, as compared with baseline EPR method in order to get their job done. In a traditional approach, the jobs are randomly distributed among the resources without grouping or considering the task priority. This is to study the effect if the users do not have the option to set their cost priority preference. The experimental results are shown here. This figure shows the relationship between the total cost and load sizes from the optimal partitioning DLT proposed algorithm without user's preference priority and is compared against baseline EPR for the different number of processors, N. From the results shown here, the traditional approach where users did not have the option to choose their preference, the cost is varying and may be exceeded their budget. In this paper, an optimal scheduling of real-time divisible load on heterogeneous cloud environment has been successfully developed. The work conducted in this research evaluated the merits of implementing worker selection strategy according to users' preference and job priorities. The experimental results suggest that the proposed algorithms can significantly benefit users under different circumstances. Future work could consider improving the scalability of the proposed algorithms, and the evaluation might be extended with more extensive settings. Thank you.